Hello again. Today we'll be modeling the lesson Investigating Liquids in Syringes. This lesson comes right after the Investigating Gases in Syringes, so students should already have a little understanding of how to increase or decrease the volume of the syringe by pulling and pushing on the end. In today's lesson, though, they will also be using a cup of water. Now, depending on your classroom dynamics, you can choose to do this as a demonstration, or if you're feeling aspirational, right, you might actually have all the students put on their safety goggles and try this lesson in pairs. We have a whole bag of syringes and cups for you to use. I'm using some colored water here. If you do end up using having students work in pairs, you may not want to color the water just to keep cleanup easy, but the coloring certainly helps in this demonstration. Okay. Now, once again, today you're going to be asking students to create models, this time of liquid matter, and construct explanations for their behavior using a model. You might start this class by first having students share some of their gas models from the previous lesson and talk about their strengths and weaknesses, or limits, if you will, before moving in to the liquids. Now, with the liquids, what you'll be doing is much the same as the gas, right? You'll be filling the graduated cylinder with liquid water. But this time, when students attempt to compress the syringe, they'll find something very different happening. If they put their finger over the end, right, and they try to squeeze down on the syringe end, they will find that it does not compress like the gas syringe did, right? And that has to do with what is going on with the particles of liquid matter inside the container versus the particles of gas matter. Again, that's what they will be trying to model and explain in the follow-up to this exploration. Now, you may also want to have students actually squeeze out the matter. Just remember that they don't want to be pointing that in the direction of anyone or anything that should not have water on it, right? So this is where you may want to model how to specifically investigate this syringe with liquid matter. That's the bell, so let's move on. Once again, we'll be turning our students' attentions to their student notebooks, where they will be asked to model the observations that they made and what they felt when exploring or observing the liquid in the syringe. Now, they may once again want to reference back to previous liquid models that they observed, but what we should be seeing in students' models this time are matter that is much more tightly packed to one another in the syringe. You'll see here that I've used a different color, much like I used the red dye in our demonstration. That might be helpful in having students distinguish between their gas and liquid models when they look back moving forward. Again, students, you'll want to encourage any students who are willing to include at least some demonstration of motion and direction. Now, this is going to be a lot trickier, a lot messier, so you can tell students it's okay if they don't show every single particle, really kind of cap their time on how much they want to work on this before they move to their after model. But they should be able to demonstrate at least some of those particles are moving, or should be able to explain that in their models moving forward. Now, as we saw in the before-after experience of compression, depending on what you did, you'll notice here in this notebook that we have compressed the model, that the syringe has actually been squeezed and there's less volume, which means students should be modeling here, all right, the fact that some of this matter has now left the syringe. Right? Now, whether that was a spray out or a steady stream, they'll want to model that. And again, we're focusing on scale here. What's happening at the really, really, really small level? So we don't want to see a drawing, a color-in picture of red stream. We want them to use particles. We want them to describe what they observed in particles. So our students are once again using particles, and they are again drawing those particles in. So what's important in our liquid model is that the matter is much more tightly packed than the gas model, but right, unlike solids, right, they are a little bit more disorganized because they are ultimately flowing around one another. They will want to demonstrate this again, either with some arrows or some sort of way to show that those particles are in fact moving. And because this model has shown the syringe is compressed, right, it's not when it just sort of pushed back when you could not actually let the water escape when you had your finger over the top, right, they'll want to model that spray or stream, whatever it is that they saw. So once again, students will use these models to also explain their thinking in the column to the right. It's important that when our students use models, they can use diagrams, illustrations, but that they'll want to use language, written language, to convey the meaning of whatever symbols and diagrams they're using. Once again, students will be building, using, and revising simple particle model diagrams to describe the observed phenomena of compressing the syringe full of liquid. They'll be using this model to demonstrate their understanding that matter of any type can be divided into particles too small to see. The idea of particles being too small to see is attributed to the cross-cutting concept that natural objects and other observable phenomena exist from the very small to the immensely large scale, which sometimes can't be observed directly. This lesson has been designed to help students meet the 5th grade standard that students use a model of matter made of particles too small to be seen to explain common phenomena. This video and associated lesson has been produced by the Burlington Science Center.